Okay, so this is the given problem. We have a CST element. Uh, so this is given x1, y1, x2, y2, x3, y3 is given. Along with that, they have given the displacement also. u1, v1 means what? At node number 1, they have given the displacements. This is u1, this is v1. Same at node number 2, we will have u2, v2. And same node number 3, we will have u3 and v3. So all the values of displacement at each node they have given. They have given the Young's modulus value. They have given mu value, that is Poisson's ratio they have given. They have mentioned that consider this as a plane stress, right? Now they are what they are asking? They are asking sigma x, sigma y, tau xy. So whatever the element stresses are there, that they are going to ask you, and then they are asking you the normal stresses sigma 1 and sigma 2, maximum normal stress, minimum normal means maximum and minimum sigma 1 and sigma 2 they are going to ask, and then they are asking principal angle, that is theta p. So these things they have asked, and we need to calculate that these things. So how we will approach this type of question? So if you remember in the previous lectures we have discussed that sigma matrix, that is a stress matrix, can be written as D matrix into epsilon matrix. Means this is nothing Hooke's law. This is generalized Hooke's law. Why this is generalized Hooke's law? Because this is valid for 2D, 3D, or 1D. Any we can say. What we are studying? We are studying sigma is equal to E into epsilon, right? This is valid for one-dimensional elements. Means a stress is equal to a strain into Young's modulus. So this is the modified. This is called a generalized Hooke's law. That is sigma matrix, stress matrix is equal to D matrix into epsilon matrix. So on the basis of this only we have discussed plane stress and plane strain derivations, right? Finally we got this equation only final. So we know this. Now in the previous lectures, when I was discussing about the concept of this type of problem, in that I have given one more relation. That relation was epsilon matrix, that is a strain matrix, can be written as a strain displacement matrix, that is B matrix. So this is D matrix, sorry, B matrix, strain displacement matrix into displacement matrix, that is delta matrix. So a strain matrix can be found by multiplying a strain displacement. B matrix already we know what is this, a strain displacement matrix into delta matrix. So let us take this as equation number 1 and let us take this as equation number 2. So now what I am going to do, I am replacing this epsilon value here in equation 1. So therefore what we need, what we will get finally, that stress matrix can be written as D matrix into, in place of epsilon we can write B matrix into delta matrix. This is equation number 3. So sigma can be written as D into B into delta, D matrix into B matrix into delta matrix. So we know here what we need to find. We need to find sigma x, sigma y. Once you will find this sigma x, sigma y and tau xy, then we will be able to find sigma 1, sigma 2 by using formula, and then we will be able to find theta p. So by using this equation only, we will be able to find this element stresses sigma x, sigma y and tau xy. So what we need now? We need these things. We need delta matrix already given. These are our displacements. We need B matrix. We know how to calculate P matrix 1 by 2a into beta 1 0, beta 2 0, right? So by using that we will calculate. Now we need D matrix. So D matrix, we know what is D matrix in plane stress condition. We will apply that. So everything we know, just we need to calculate and then we need to multiply. We will get the sigma x, sigma y and tau xy values. So first I am going for this D matrix. So as it is plane stress condition, so D matrix for plane stress condition, plane stress condition, for plane stress condition, the D matrix can be written as E upon 1 minus nu square into 1 new 0 new 1 0 0 0 1 minus mu by 2. So this is the matrix D matrix when coming to plane stress condition. So by solving we will get directly, just replace this value, new value we know E value, everything they have given. So by solving this we will get 56 into 10 to the power 3. What we need to solve? Nothing, just replace all the values in the same units. Just please check the units before keeping this value. That's it. 410 140 and 1.5. So we got D matrix. Now coming to this B matrix. So for B matrix we can write this B matrix as, B matrix we know that is 1 by 2a, beta 1 0, beta 2 0, beta 3 0, then we have 0, gamma 1 0, gamma 2 0, gamma 3. Then we will have gamma 1, beta 1, gamma 2, beta 2, gamma 3, beta 3. This is B matrix. So here we will find beta 1, beta 2, beta 3 by using that relation between y and x. By using x relation we will find gamma, and by using y relation we will find beta. And then we need to find this A also. So area, how to calculate? We know how to calculate area. So let us calculate area first. So area matrix can be written as 1 x1 y1, 1 x2 y2, 1 x3 y3. So that will be 1 by 2, 1. From here we will write x1. This is x1. 1 means x1 y1, x2 y2, x3 y3. So by taking these values, the matrix is going to be 1, 10, 8, 1, 15, 5, 1, 18, 12. So if you will solve it, you are going to get this area as 22 mm square. Now we will find beta 1, beta 2, beta 3. So beta 1 is nothing. Beta 1 can be written as y2 minus y3. So by putting all the values, we will get minus 7. Beta 2 can be written as y3 minus y1. And beta 3 can be written as y1 minus y2. So just put the values, you will get this as 4, you will get this as 3. Now we will find gamma 1, gamma 2, and gamma 3. So gamma 1 is going to be x3 minus x2. So x3 minus x2. So we will have x3 minus x2, we will have 3. Then we will have x1 minus x3 minus 8, and x2 minus x1 5. Just you need to, nothing you need to remember. If you remember a single one here, 2 3 3 1 1 2. So same here, just you need to interchange. For gamma it will be, here it is 2 3, so here it will be 3 2. Here it is 3 1, so it will become 1 3. Here it is 1 2, so it will become 2 1. So it will be easy for you to remember this thing. So we have found all the elements of this B matrix, so we can write this B matrix now. So B matrix can be written as 1 by 2a. So 1 by 2a means 1 by 2 into 22, means I can write directly 1 by 44 into minus 7, 0, 4, 0, 3, 0, then 0, 3, 0, minus 8, 0, 5, and then finally 3 minus 7, then minus 8, 4, then 5 and 3. So we got this B matrix also. So what is unknown now? D matrix calculated, D matrix calculated like delta. So delta, everything is given, just we will arrange these things to get this delta matrix. So let us write this delta matrix now. So delta matrix will be what? Delta matrix will be directly at node number 1 u1 v1, node number 2 u2 v2, node number 3 u3 v3. Just put all the values is given. Just remember one thing, the values are given in micrometer, convert it into mm because everything is given in mm, right? Area we have calculated in mm square, and so everything we are taking in an mm. We are taking these coordinates also in mm. So just convert it into mm. Micrometer is given 0.2 micrometer is given, so just convert it into mm. Nothing, just divide it by 10 to the power 3 means into 10 to the power minus 3. So 2 into 10 to the power minus 3 will be mm, right? So we can write 2 by 10 to the power 3 also. So from here directly I am taking 1 by 10 to the power 3 outside, because every whatever the value is given, if we will divide it by 10 to the power 3, we will get it to mm, right? So by I have taken that as constant outside itself and just put all the values. U1 value is given 2, then 1, then we have 0.5, then 1.5, 1.2 and 2.8. See, I have kept all the values. So we got each and everything. Now just what we need to do, we need to multiply the things. So we can write now stress. So what is a stress now? Stress, we know we have a stress as sigma x, sigma y and tau xy. We will have a stress sigma x, sigma y and tau xy. Elementary stresses we will have either in x direction or in y direction or CR, that is tau xy. That can be written as, now see, stress can be written as d into b into delta. So what is d matrix now? Here we have d matrix. So d matrix into b matrix into delta. So d matrix, is 56 into 10 to the power 3 into 410, 410, then we have 140, and then we have 1.5. So this is D matrix. Now B matrix. So B matrix is 1 by 44 into -7, then 0, 4, 0, 3, 0. Then we will have 0, 3, 0, -8, 0, 5, and then we will have 3 minus 7, -8, 4, 5, 3. Now into delta matrix. So delta matrix we have into, these all are in multiplication, 1 by 10 to the power 3. We have delta matrix as 2, 1, 0.5, 1.5, 1.2, 2.8. Now just multiply, we will get sigma x, sigma y and tau xy. So you have to multiply the matrices. Now here one thing we need to see is, again before multiplication what we will check, this is our 3 by 3 matrix, right? This is our 3 by 6 matrix. This is 3 by 3, this is 3 by 6, and then we have 6 by 1 matrix. So first we will multiply these two. Whatever the thing is outside, we will take outside these two, multiply these two matrices. So once you will multiply this, 3 and 3 will cancel out, the remaining matrix, final matrix, we will get 3 cross 6. And then again we will multiply this with this matrix, that is of size 6 by 1. So this again 3 by 6 by 6 will cancel out. So final matrix we are going to get as 3 by 1 matrix, right? So 3 by 1 matrix means what? What is the size of this matrix? This is only our 3 by 1 matrix. So we will have directly sigma x value, sigma y value, tau xy value. So after multiplication, you will get the result something like this. After multiplication, okay, we will see. After multiplying everything, what we are going to get? See, we will get in this one sigma x, sigma y, tau xy will be equal to, after multiplying we will get the values, and we will get the values as, let me write the values directly after multiplication, minus 36.4, then we will have 14.76 and 29.40. so directly you will get this matrix after multiplication. So can't you say sigma x value from here? Yes, obviously. From here, what is the value of sigma x? Sigma x value is minus 36.40. Now what will be the unit? See, everything we have taken in Newton load and mm in length, so Newton per mm square. Similarly, sigma y value, from here we will get 14.76 Newton per mm square, and tau xy value we will get from here 29.40 Newton per mm square. So we have sigma x, sigma y, and tau xy. So first three things we have calculated in this problem. Sigma x calculated, sigma y we have calculated, tau xy we have calculated. Now they are asking sigma 1, sigma 2, and theta p. So directly formula, just what we will apply now, we will apply the formula directly for sigma 1 and sigma 2. What is the formula? So sigma 1 will be half sigma x plus sigma y plus root under sigma x minus sigma y whole square plus 4 tau xy square. Just we have sigma x value, right? Minus 36.40. Sigma y value, sigma x, sigma y, tau xy, everything we have calculated. So from here directly we will get sigma 1 value 28.15 Newton per mm square. Just you need to put these values, and by using calci you will calculate within a second. Similarly, sigma 2 value will be same, half sigma x plus sigma y. Here in place of plus we will keep it here minus. The remaining thing is going to be same. Only the thing that will change, in place of plus here we will put here minus. So this will be sigma x minus sigma y. You might have come across these formulas in strength of materials. Will be, if you solve it directly, we will get minus 49.79 Newton per mm square. Now what we need? We need theta p, right? So one more thing that is required is principal angle theta p. So theta p, principal angle, what is the formula for theta p? That is half tan inverse 2 tau xy upon sigma x minus sigma y. So if you know sigma x, sigma y, and tau xy, you can calculate the remaining sigma 1, sigma 2, and theta p. So once you will keep these values of tau xy and sigma x and sigma y, you will get this as minus 24.5 degree. This is theta p. So we got all the values. We got theta p value, we got sigma 1 value, we got sigma 2 value, we got sigma x, sigma y, tau xy. So everything we got in this problem. So just you need to remember this formula. Just you need to remember this. I would not say another formula. Just you need to remember this relation. I would say this is a relation between stress, displacement, compatibility matrix, and strain displacement matrix. This is compatibility matrix, right? This is compatibility matrix multiplied by strain displacement matrix, strain displacement matrix, and this is displacement matrix. And matrix. So if you will multiply these matrices, you will get stresses. So this relation you should know. If you know this relation, you can find sigma x, sigma y, and tau xy. From there, if you know sigma x, sigma y, and tau xy, from there you will be able to find sigma 1, sigma 2, sigma 3. Now coming to this, if in place of plane stress condition, if they will mention plane strain condition, then what will they can ask that also. In place of plane stress, they can give plane strain. So nothing is going to change. Whatever the process we have followed, same thing we will follow. Only the thing is going to change is this D matrix. Only this D matrix will change. Here we have taken the formula for this D matrix is we have taken the formula for D matrix is this. But whenever the plane strain condition will come, when plane strain condition, if they will write use plane strain condition, if in the same problem in place of plane strains they will give plane strain, every value is going to be same except this D matrix. So this D matrix then we will take for plane strain condition. What the D matrix we are going to take? So the D matrix we will take E upon 1 plus nu into 1 minus 2 nu, E upon 1 plus nu into 1 minus 2 nu. Here 1 minus nu 0, then again nu 1 minus nu, and then 0, and there we will have 0, 0, 1 minus 2 nu upon 2. That's it. In place of this, we will use this plane strain condition. Except this, nothing is going to change. Nothing. The remaining things will be same. So I hope if they will ask you to solve the same problem or some other problem also, the same type of problem using plane strain condition, you will be able to solve that problem, right? So this is all about the problem based on elemental stresses, calculation of element stresses for a CST element using this concept of stress relation between stress, compatibility matrix, strain displacement matrix, and displacement matrix. Okay.